Okay, we're back for another video, and this time I've got serendipity back. If you dig through my old videos, you'll find a couple of little videos where we set this up as a camper for the senior advisor here. And today we're adding a 15 amp power socket that should go through, and hopefully to a power point with RCD on the inside, and ground it out so it's according to safety standards. Now on the inside we have a thread wire here we used previously when we've pulled some cable through to run the low voltage. We're thinking about putting the power point here, which is fairly right. We have the door fully retracted here, so that gives us an idea of what our clearances are. And so we might just rip this little cover out of here, see what's going on in there. With the seatbelt point removed here, this is some of the cabling we've got running around. There's a couple of different DC circuits. Goes up to a lithium battery up the front there. Each one of these circuits is fused individually, so that's our spare wire. There is a little protector here that would have been for the seatbelt. We're going to try and remove that and see what's going on behind there. Alright, so we've established that on this side, in here, there is a funny bracket that goes along around the corner here. So lower down seems to be fairly clear. So we've got this little plastic bit out. We can see through here there is a clear little port through there that'll be nice. So if we poke a drill bit through here, we might be able to make a pilot hole, and then we can drill back from the other way and get our center correct. And with some investigation,
that's the point, you've got to be able to open it. Oh, that's, but that part.
Yeah, that part there.
Yeah, with some investigation, we've worked out there's a fair bit of open space in here. We might be able to fit it if it's not going to interfere with the door.
Lift it up.
All right, and we've got Mr. Middo as a guest repairer here as well. He's going to come and help remove some stuff.
Do I need to remove anything else out of your way?
No, it's all right. Okay, so we've got our hole marked from the inside, and we'll put a little bit of a, we used a screwdriver as a center punch here. Now we're going to get a nice sharp but small drill and get our center hole drilled, and then we can go from there. Right, now we check that it's in the right spot. Measure twice, cut once. We probably do need to come over probably about 10 millimeters to this side here. Okay, let's check that one. That one's about bang on, so let's swap our hole saw in. All right, point of no return now. There we go. Right, now in the absence of something like row coal, we're going to use a bit of WD-40 as a cutting compound. I'm looking at the teeth here now, they've cooled off and they're clogging up a bit, so WD might help clear them up. Biting in a little bit better now, but we'll just basically rinse and repeat, and we'll get there over time. Okay. All right. Alright, we did well. We didn't even scrape the subframe. We're in that little hole there, so we should have access from both sides. It'll be good. We are probably just about aligned enough. We couldn't really go any higher because there's the top of the subframe there, and this is the bumper here. So this is about the only spot we can realistically get this in comfortably. Okay, we have our tapered edges go down, and we have a bit of room to maneuver stuff around. We want to make sure that this actually does fit in the hole. It does. With a little bit of wriggle room, that's good. We've got a bit of side to side, but that was necessary because it actually calls for an ogive shape hole. Ogive is actually a word. Learned that when I was doing model rockets. Right, now we've got our hole sorted. We're going to put our cable in first. We'll thread through, we'll screw on, and then hopefully we won't have to touch it again. All right, now at this point we're dipping into electrician territory. I do have an electrician that will be coming to check my work and fixing anything I get wrong. But this is where I say don't do this at home, especially with this is 240 volt stuff. You can kill yourself or somebody else, or set fire to things you own. A whole bunch of things can go wrong, so don't do this stuff yourself. Get an electrician to do this bit. In any case, this is a 15 amp socket. This is 2.5 millimeter solid core, good for 15 amps, even though the total load on this will be probably 10 amps or less. and putting a 10 amp socket on the inside, which is not illegal. If you're doing this with an extension lead and you were putting a 10 amp plug and a 15 amp socket, that would be. But in this case, this is perfectly fine to do. This will be tested to ASN ZS3760 standards. We'll do an earth bond test. I've got a trip time tester. We'll do all of that. In any case, we just want to wire this up for now to put the socket in the wall. All right, that's more or less wired. One of the things you can be tempted to do is to over tighten these, and they will rip the standoffs off. Don't do that, because then the plug pushes through on the inside when you put a plug in. That's pretty much wired. I will shove some heat shrink up here, I think, just to protect that, and we should be all right. We have our earth bond done. This is a virgin hole with a self-tapping screw, star washer underneath. We have both crimped and soldered this connection, and we can poke through this hole and go up to our power point. Okay, so we'll poke cable through. Yeah, don't pull, we should be right. I have lost my help to the US presidential election at the moment, watching that on TV with popcorn. So now, all right, that's in. Let's find our gasket, which is the bit that I forgot to put on. And the gasket. You know, I've got a history of doing that with swing stage leads. 100-meter long extension leads that go on swinging stages on the side of buildings. If you forget to put the shroud on when you do a plug on one of them, you've got to start all over again, or you've got to thread it over 100 meters of lead. And don't over tighten, because you don't want to strip the screws or break the plastic or over pressure the gasket. Okay, so now we have an RCD protected power point that is also double pole switching, meets all our requirements. We had hoped to probably mount it in here, but that hole there might not be good enough. So we're going to find potentially here might work well, and we'll work through the panel. This we can rethread in behind the panel to come out behind here nicely. But I reckon the power point there is probably going to be best. We'll check with what normally goes there and make sure we can actually fit it where we need it. All right, we have a hole, the top of which is mostly level, and that should fit in nicely. We'll probably need to put some washers or double plates on the back, but that fits through all right. Okay, and we're mounted, and the screws don't go too far in, which is nice because there's a panel behind that they have to not interfere with. And these are mild steel, so I can trim them off with a pair of my mini bolt cutters if I need to. But we're happy. Now we've got to wire it up and put an extra line off that earth to go to the vehicle chassis. Right, our panel's in. We do need to put the bolt back in there, but that's in quite firmly. The panel is clipped in right, but once we put that bolt in, it'll be quite firm. The fridge might even fit in here still. Okay, so it's time to plug in and test. So we'll plug in from the outside here, and I've got an RCD trip time tester here. So we're going to trip back to 10 milliamps here to start with at half the rate of trip. And so we're going to plug into this, and this will tell us if we've got power first and if our neutral and earth and everything are all connected. So let's see, we should be able to go reset. We should have power. Is it on? We're plugged in. Yeah, no, don't appear to have power at the moment. All right, we're going to use our volt pen. Yes, our lead's active. We might have hooked up to the wrong terminals on the point. So yeah, so no power available on that side of the socket. All right, let's go investigate. All right, we did hook up to the line connections and the earth, so that should technically be working. We'll keep investigating. All right. We have power available to our hot wire here. That is working, and that is, according to this, in the right socket. So we're just going to take some time and have an idiot look and see what we might have missed. All right, we had a bit of a test here. Now there are two RCDs on the line further up here, so I'm pretty safe. But we have a hot wire through here now, and we have, hopefully, hot wire in here. Yes, we do. Okay, we'll put it back on the wall. Okay, we're back on the wall again, and we can find power behind the panel, and definitely in there. We're looking good. So what we're going to do here, firstly we're going to push the self-test, well we'll do this test first. So we're going to do half rated trip, 10 milliamps, which would be 5. No, we don't have any trip. Let's go rated trip. Nothing at 10. It should trip at 30, which is where it's designed to. Okay, so it's just tripped, I think. And we've got no power now. Okay, that has worked. Okay, so we had a mainboard trip. Now, crucially, we've got power to neutral and power to earth, correct. We're going to hit the test button on the actual point itself, which it's just popped. So that works. We can reset from here. So the inbuilt tester is working. And what that does is that puts a resistor between active and earth, and that should trip it. But crucially, it didn't trip the main board. So either way, we know that the ground is working because it wouldn't trip the main board if the ground wasn't working. So we're pretty well happy with that. All right, we're going to test with the little portable heater on a low setting at the moment. And that's warming up nicely. And this is good. There's no need to use the gas buddy heater and have the windows open. You could close it down in the really, really cold, icy weather. And yeah, you could warm up the back of it. So we're looking good. The end result here is going to look fairly low profile, which is nice. So we'll off to the electricians and get their opinion on it and get them to stamp a test certificate on it. I've got a test and tag certification, but we still want the electrician to check it and maybe put bootlace connectors on and all the rest that is required. So either way, we've got half the hard work done. Anyway, we'll see you on the next one. It probably won't be serendipity. It could be the 6-wheeler because everybody keeps asking about it. So we'll see what we can do.